Page 2 of the Year 8 test for 2008, Term 1, Test 3. And I'm on the second page of the main test. Right, the question says, for the numbers 8 and 12, find the highest common factor. Well, let's list out the factors of 8 and 12. So the factors of 8 would be 1, 2, not 3, 4, yes, not 5, or 6, or 7, but 8. And for 12, the factors will be 1, 2, 3, 4, they are all 1 times 12, 2 times 6, 3 times 4. So I'm remembering my times tables here, folks. 5, no. 6, yes, 6 times 2. 7, no. 8, no. In fact, we've got to 6 times 2, and we've got to half of 12, so the next one's going to be 12. Alright, now we've got the factors. Now, the question says find the highest common factor. Well, the highest common factor, the highest number they have in common, well, they have 1 and they have 2, but 4 is the highest common factor. So the HCF of 8 and 12 is equal to 4. Right. What about the lowest common multiple? Well, let's write out the multiples. 8, 16, 24. Now, my times tables tells me that 24 is in the 12 times table, so I think I've probably gone far enough. Alright, let's go. 12 and 24. These are multiples of 8, these are multiples of 12. And here is a common number. This is common to the multiples of 8, or the 8 times tables, and the 12 times tables, or the multiples of 12. So the lowest common multiple, the LCM, of 8 and 12 is equal to 24. Okay, question. Whoops, we've gone right out of focus again. After a fiddle. Come back. There we go. Zoom up a bit. Obviously, if there's not enough writing on the page, the autofocus in this camera goes searching. Alright. Question 7. Use a factor tree or factor ladder. Again, we haven't been using a factor ladder. Perhaps the Year 8 teacher who wrote this particular test was using factor ladders, but we've using factor trees only. Excuse me, trying to deal with a sneeze here. Alright, so let's start with the factor tree. So let's start with 200 up the top. Now, what about, what if we go 50 times 4? 4 and 50. 4 50s are 200. You could choose another pair. It doesn't matter. It'll work out the same, provided you're consistent and you're accurate down the line. So 4 is 2 times 2. 2 times 2 is 4. So they're primes. Now what if we go 10 times 5? Now 5 is a prime. Now what about 10? 10 is 5 and 2. 5 and 2 are primes. Now you could come up with something else. You could have gone, well, we'll do it. 200, what if you did 200 by 2 times 100? 2 times 100 is 200. Now 2 is a prime number, and let's split 100. Let's go, I don't know, again, you've got a range of choices here because there are quite a few factors in 100. Well, let's go 25 and 4. Then 25 is 5 times 5, and 4 is 2 times 2. So there we go. They're all at primes, the end of the branches here. So we've got 2 times 2 times 5 times 2 times 5. 2 times 5 times 5 times 2 times 2. It's all this, they're both the same. So I've not left myself much room here. So I'll try and write it in here. 200 equals 200 equals 2 times 2 times 2 times 2, and I'm going to write that as 2 to the power of 3. If you've got 2 times 2 times 2, that's good. And I've got 5 times 5, or 5 to the power of 2. Right, so there's my final answer, and there's two ways of getting it. Right, show all your workings for the numbers 36 and 54. The highest common factor. Well, this is difficult because we're going to need to find the prime factors of these. This is actually quite a tough question. This one, put it back in. Show all the workings for the numbers 36 and 54. Find the highest common factor and the lowest common multiple. Okay, well we're going to need, I'm going to use two factor trees. Mr. Morgan's group seems to have used factor ladders, but I'm going to use factor trees for this. So we'll start with 36, 9 and 4. You could, as long as you are accurate with your factors, doesn't matter which factors you choose here. 9 is 3 and 3. I've got 3 times 3 and 2 times 2 for 4. 2 times 2 is 4. 3 times 3 is 9. 9 times 4 is 36. That's correct. Check your workings back, actually. Check your workings back through your factor trees, back through your factor tree, back through your factor tree. Make sure that factor tree is actually accurate. Right, now let's do 54. 54, 6 eighths of 54, there's my times tables. 6 eighths, whoa, big mistake, Mr. Mont. 6 nines are 54. Okay, 6 nines are 54. Is that right? 6 eighths are 48. 6 nines are 54. Yep. Okay. Now 6 is 2 times 3, and 9 is 3 times 3. All right. Okay. Now I've run out of for my highest common factor over here. This question here. This is what I need. I've got everything I need here. Now my highest common factors. So 36 is equal to 2 times 2 times 3 times 3. And 54 is equal to 2 times 3 times 3 times 3. Now to find the highest common factor, I use all the common factors, or the common prime factors, and multiply them together. So circle them. There's a 3 and a 3 there, a 3 and a 3 there, a 2 and a 2 there. They're common, right? So then I write the highest common factor. Now I'm just being a bit technical and fancy here, as long as you've got a right answer. But you're going, these are difficult numbers. Listing out the factors, you're going to list out all the factors of 36, then all the factors of 54. Really, it's better to use the factor ladders like this, the factor trees like this, is equal to 2 times 3 times 3, which is equal to 18. Okay? Now that's a tough one. You'd have to be pretty confident with your factor ladders, factor trees, and with your working with your prime factors there. Right, let's have a look at the lowest common multiple now. Okay, let's see if we can keep it all in the frame. Alright.